different spot. Thank you. I got it. All right. Again, my heart just stopped. Like, what happened to record button? I found it. All right, so let me print this problem out and we'll work on this one together. Let me get another. Let's see. Enter. There we go. Okay, just take a second for me to print this one. There we go. Okay. Whoops. I didn't need that one to print. Okay. Here we go. All right, we're going to have to go back and forth on, oh, no, wait, that's not the right one. Hold on a second. I printed this wrong one. Here we go. We're going to have to go back and forth on this one again. So let me go ahead and share the screen. Okay, and we are recording now, so we're good. Okay. All right, so this one's that, excuse me. So here's the table. Now, what I need to do on the table is get the totals. That's why I had to print it out because I can't really do that on the screen. So let's go ahead and total across on each row. So I'm going to do it off to the side. So 321 plus 263 plus 249 plus 120. And I came up with 953. Remember, your numbers might be a little bit different because every time it regenerates, it gets different numbers. 30 plus 58 plus 40 plus 14 is 142. And then we've got, this is 351 and 263 plus 58, 321, 249 plus 40. Oops, sorry, 40, 289. 289, I'm running out of space here. 120 plus 14 is 134. And then let's just check the total. 953 plus 142. I got 1095. And let's check across the bottom to make sure we got the same number. 289 plus 134. 1095. Yeah, I got the same thing. Okay. All right. So assume that selections are made with replacement, and we're going to select 2 orders, and we want to know the probability of getting 2 orders from restaurant D. Okay, probability. So basically it's saying restaurant D and restaurant D. Okay, so the first time I go into the table, I have how many orders to pick from? 1,095. How many of those are from restaurant D? 134, right? Okay. Now we're going to replace it. So we picked an order, look at it, we just see if it's accurate or not. We're going to put it back in, and then we're going to pick again. Now, what's the probability that we get restaurant D on the second draw, given that we put the first selection back in? Is it going to change? Is it going to be any different? It's not, because we put the first order back in. So we still have 1,095 orders, and we still have 134 from restaurant D. Okay. And then you'll go ahead and you'll multiply those together, and I'll do that offline. 134 divided by 1095, and I can just square it because it's the same thing. So it's 0.014976. I probably don't need that many decimals, but for my problem, now yours might have slightly different numbers. Round to 4 decimal places as needed. So 4 decimals here would come out to be 0.01, actually 0150 for 4 decimals, because when I start to round at this location here, it's going to round up. So it's going to be 0.0150. Now they ask you, are these events independent or not? So are the events of picking the first order from restaurant D and then the second order from restaurant D independent? They are or they are not? Go ahead, Chris.
Just a fast question. If we put for the midterm, if we had, say our answer was 0.015 and we forgot to put the last 0.
No, it'll count it correct.
Okay, the system will?
Yes.
Okay, Rosa, thank you.
And just to let you know, when you take the midterm, I go through and I check every wrong answer, and if it was misgraded, I will give you credit.
Thank you so much for doing that, Dr.
Yeah, I
Lee.
know I do, just to make sure that it didn't, that you didn't round off incorrectly or something. All right, so let's go back over actually to the problem in my math lab so we can enter the answers. So let's go ahead and make sure we got the right answer here. Oh, that's not the my math lab part. Hold on a second. Here we are. Okay, so we got, I said we had 0.015, 0.015. Now, are the events independent or not? The probability didn't change, so therefore the events are independent because choosing the first order doesn't affect the probability of the choice of the second order, because you saw on my piece of paper, the two probabilities were exactly the same. Let's check and see if we got it right. We did. All right, now they want you to switch it around. I'm not going to print this. We can just write this on the paper. Now they want us to sample without replacement. So let's go back over to the paper and sample without replacement. So how's that going to change it? So this time, we always abbreviate in statistics, WR means with replacement, WOR means without replacement. So now what's the probability of D and D? Okay, the first time I go in, it's 134 over 1095. Now, when we're sampling without replacement, we always assume that the first event occurs. So we're going to assume that we got an order from restaurant D. I'm not going to put it back in. So how many orders are left to pick from restaurant D? There's one less, so it's going to be 133. Now I didn't put that order back in, so how many total orders are left to pick from? One less. Okay, so the second probability changed because we didn't put that first order back in. Okay, these events are not independent because what happened on the first pick influenced the probability of the second event. Okay, does that make sense? I'm not going to finish this problem up. I think you can work it from here. Questions on that? So do you see the difference between if you sample with replacement? Go ahead. Question? Amber, you have a question or are you okay?
I'm okay. Thank you.
Okay. All right. So in the sample with replacement, notice the probability didn't change. When I sampled without replacement, the probability of getting restaurant D on the second draw has changed because I got an order from restaurant D on the first draw and I didn't put it back in. And I'll let you multiply it out. Because these numbers are pretty big, the probability is going to change that much, but it's going to be different when you multiply those two fractions together. Okay. So whoever asked me for that, does that make sense? I heard a couple people say they had trouble with this one. So does that help?
Yes, thank you.
You're welcome. Okay, anybody else? Let me go back to my math lab, my stat lab. Anybody else have questions that they want to go over from the homework due tonight? 4.1, 4.2, and 4.3.
Can we do 16, please?
From this section?
Yes, ma'am.
Okay, I'm not going to do the whole problem, but it's going to be just like the one we did before. Now, in this case, because they didn't tell you if you're sampling with or without replacement, you're going to assume you're sampling without replacement. So it says if 3 different orders are selected, find the probability they're all from restaurant D. So the first time you go in,
decreasing the numbers, right? You just keep
Yes.
decreasing the numerator and the denominator
Yes.
as you go along. Okay.
Yep.
Okay, that's what I thought.
Perfect.
Thank you.
Yeah, because it's exactly the same as the one we just did. I didn't want to print it because I'm going to have to get all the
No,
totals.
I understand.
You know how to do it now. Yeah.
Yes,
Because
ma'am.
it didn't say anything, you're going to assume this one, because it says they're picking them from the table, you're assuming it's going to be sampling without replacement.
Okay.
Yeah, let me look at their help and see if they say that. Let's just take a look and see, because I think they tell you in the help there. Yeah, they're talking about here.
Wait,
Conditional probability. In this situation, simple event selecting the order from the restaurant. Yeah, so they're saying that you're sampling, there we go, without replacement. Yep. Yep. So because they didn't differentiate and you have a finite number of orders in the table, you're going to assume it's without replacement. Okay, anybody else? I think I have a question over here. Let's see. Oh, come on, where's my chat window? Oh, I can't see it.
He said you assume it's always without replacement unless they state otherwise.
If it's a finite number of things in the table. Okay, you had some questions. Let me just see for a second, because I think you had some. Remember, we did one last week. We did one where I'm trying to see if you have one in here like I'm thinking of. Let me just click through real quick. Wait a second, maybe this
Welcome.
one. No, that's a complement question. That's still, I think these are all from the tables. Okay, no, it's not in this section. I was thinking of a different kind of question. No, these are all going to be, if there's a table of data, unless it says you're sampling with replacement, you're going to assume it's without replacement. All right, anybody else while we're here? .1, 4.2, or 4.3. Those are the homeworks due tonight.
I had a question about formal multiplication rule.
Uh-huh.
That's 4.2, chapter 4.2.
Okay.
When it comes to like P, A, and B equals P, A times P, B divided by A, and I keep getting thrown off.
Okay, that's a conditional probability.
Yep.
Is that what you're talking about? Because that's in 4.3.
No, it's in 4.
Because what we just did, because if we go back to what we were just working on, if I pull this one up here, so in this case here, this is probability of restaurant D and restaurant D. So the first one, so if we let's let event A, I think this is what you're talking about, but I'm not sure. Event A be pick D.
Oh, here I can show
on
you.
first draw. And then event B will be pick D on second draw. So the probability of D and D using the multiplication formula you just talked about would be probability of A, and then it would be probability of event B, oops, given A had occurred. This is the probability of A, this is the probability of B given A occurred.
Okay.
If that's what you're talking about.
Yep, that's it right there.
Yeah, so this is the conditional probability right here. So this is the probability of event B, which is get a D on the second draw, given that we got a D on the first draw. That's the conditional probability part. In this case up here, we just had to do probability of restaurant D times probability of restaurant D because it didn't change, because they're independent. So up here, we basically did it as probability of A times probability of B, unconditionally. And they happened in this case to be the same probability. Because the events are actually the same, but you're doing them on the first draw and the second draw. So this is what you're talking about. This is the conditional probability part right here.
Okay.
So we're finding the probability of getting restaurant D on the second draw, given we got restaurant D on the first draw. And how that changed the probability was there was one less restaurant to pick from, and there was one less restaurant D order to pick.
All right.
That makes sense?
Yep.
I think that's the one you're talking about.
Yeah, that's the one I'm talking
Okay.
about. Here, I mean, I could show you on my thing. I'll let you see it.
No, I can't. I have to show. Hold on a second. Let me
Yeah.
stop. Let me
Don't
see.
worry
Let me see
about
if we
it.
can get you up big. And
Yeah,
see if
that. Oh, that was it right there.
that was it. Okay, so does that make more sense now?
Absolutely.
Okay, good.
Yeah.
Good.
Thank you.
All right.
Thank you.
You're welcome. All right. Anybody else while we're here? Last chance. 4.1, 4.2, 4.3. Okay. Going once, going twice. That's it. Okay. All right. So let's look at the material tonight. Now, tonight we are going to use Statcrunch for some of these. So just be aware of that. We're going back to Statcrunch. You didn't use Statcrunch at all last week, or for the material from last week. But this week we will use Statcrunch for some of the problems. All right, so let's take a look. So we're going to be learning about probability distributions, and specifically about discrete probability distributions. So we've got a lot of definitions in here too. So let me put this up here. So a probability distribution First of all, let's talk about a random variable. We need to define that first. A random variable is a variable that has a single numerical value determined by chance for each outcome of a procedure. And the probability distribution lists all the values of the random variable and their likelihood or their probabilities. And we can put that together in a table, in a formula, or in a graph. And again, this week we're going to learn about discrete random variables where there's a finite collection of values that the random variable can take on. In 2 weeks after the midterm, we'll learn about continuous random variables. And we'll learn about the uniform and the normal distribution. But for right now, this week, we're going to focus on discrete random variables. So for a probability distribution, it has to have 3 requirements. There has to be numerical outcomes for the random variable. Okay, it has to have numerical outcomes. And there have to be probabilities associated with those outcomes. When we add up the probabilities, we have to get 1. And then finally, each probability has to be between 0 and 1. So sort of like what we learned about with probability. That's why this goes along with the last section. The parameters of a probability distribution, now these are parameters and they're not statistics because we're talking about a distribution. We're not talking about a sample, we're talking about a distribution. The mean of a probability distribution, don't worry about these formulas because you're going to use Statcrunch to do this. Basically for the mean, you're taking each value of the random variable, the discrete random variable, multiplying it by its likelihood, and then adding all those values together. And what this tells you is what's the expectation in the long run for this particular discrete random variable. So if you did it over and over and over again, what would you expect on average to get? If you took MGF 1106, we covered expectation in that course. And that's exactly what this mean is. The variance of the probability distribution is given by the formula here. Again, don't worry about the formulas. We're going to use Statcrunch to do the calculations. So put that note right here because these are pretty complicated formulas. Note for rounding off, carry 1 more decimal place than the number of decimal places used for the random variable. So if they're all integers, then you round to 1 decimal. Generally, what you're going to be working with are going to be integers. So you're going to round to 1 decimal place. And again, the expected value that I mentioned is the same thing as the mean of the probability distribution. So it's the theoretical mean outcome for an infinite number of trials, and we call that the expected value. What would we expect on average if we did this particular experiment over and over and over again? And we denote that with a capital E. And the mean value, E, becomes mu. And again, there's that same formula. And again, if you took MGF 1106, we covered expectation in that course. Now, again, we're starting to introduce the concept of inferential statistics, and here's another way of looking at it with what's called the range rule of thumb here. And we introduce this in 3.2, but we can also talk about it here with our random variables. And again, we can take the mean minus 2 standard deviations. That would be a significantly low value, or we can look at the mean plus 2 standard deviations, and anything above that would be significantly high. So just like we talked about in 3.2. It also can apply to a random variable. Okay, same thing down here. And then we also have a rare rule for inferential statistics, which again, we talked about earlier. Usually we use a probability of 5% or less. If under a given assumption, the probability of a particular outcome is very small, usually again, we're going to say less than 5%. And the outcomes occur significantly less than or greater than what we expect with that assumption, we conclude the assumption is probably not correct. And again, there you'll see that 5%. So that's consistent with what we talked about before. Okay, so let's take a look at some problems. And the first is going to be determining if first of all, is it a random variable at all? And then if it is it discrete or continuous? So let's talk about these. So the number of spins of a roulette wheel required to get the number 7. Is that a random variable? Remember, a random variable has to have a numerical outcome. So think about this. If we're spinning the roulette wheel, what kind of outcomes would you expect in order to get the number 7? What kind of outcomes are we talking about? Anybody want to try? What kind of outcomes would you get?
Numerical?
Yeah, numerical, right. Yeah, because it might take you 2 spins, it might take you 500 spins, but they're going to be numerical. So it is a random variable. Is it discrete or is it continuous? Now, if it's continuous, remember continuous variables, they take on an infinite number of values. If it's discrete, they take on in a certain range a countable number of values. So is this discrete or continuous?
Discrete.
Discrete.
Yeah, it's discrete, definitely. Yep. And then how about responses to the survey question, which political party do you prefer? Is this first
It's not a random
variable?
variable.
It's
There's no
not. That's-
numerical value.
Yep. A lot of times we abbreviate random variable with R dot V dot. This is not a random variable because it doesn't have numerical outcomes. How about the exact foot length of humans? Random variable?
Random variable.
What kind?
Continuous.
Yes, it's continuous because it could take on any value in a particular length, whatever, I don't know what lengths we would use, but you know, anywhere from 0 to, I don't know what the biggest foot is, 15 inches, I'm not sure, but anyway, continuous. Shoe sizes such as 8, 8.5 of humans. Is that a random variable?
Continuous?
Is this continuous? Think about shoe sizes. How do they come out? Do we have an 8 1/4?
No.
No,
Okay.
we don't have an 8 and an 8. So this must be,
Discrete.
this is discrete.
Great.
pH level in shampoo brands. You may not know this, but is it, first of all, is it a random variable? Is that a numerical outcome?
Yes.
Yes. Continuous or discrete?
I would say continuous.
Yeah, it is continuous. Yeah, I probably should replace that one, but that is continuous. pH can be measured on a continuum. Eye colors of statistics students.
Discrete.
Is it a random variable?
Not a random variable.
It's not a random variable. Not a random variable because the eye colors are not numbers, they're colors. Okay, it's a discrete variable, but it's not a random variable. Okay, so for the next couple here, let's see what we're going to do here. Determine if, okay, so if we want to find out first if it's a probability distribution, and if it is, then we're going to go over to Statcrunch and find the mean and standard deviation. If it's not a probability distribution, why? So remember there were 3 requirements. Had to have numerical outcomes, which this one has. Each probability had to be between 0 and 1. And then what was the last thing that had to be true about the probabilities? They have to do what?
They have to total 1.
Yes, they have to add up to 1. So we're going to go ahead and check and see. So 0.493 plus 0.25 plus 0.127 plus 0.064. Uh-oh, doesn't add up to 1, does it? Adds up to 0.093. 0.934. Okay, so this is not a random variable because the sum of the probabilities, and it should come pretty close to 1. It could actually be 0.99 or 1.01, but it has to be pretty close. So this one's not a random variable. It doesn't meet the criteria for a random variable distribution. How about this one? Numerical outcome. Each probability is between 0 and 1. And then what do we want to do? We want to check and see if these add up to 1. So 0.358 plus 0.439 plus 0.179 plus 0.024. Bingo, this one adds up to 1. Okay, so I should have set this up before class and I didn't. So what I'm going to do is I'm going to go over to Statcrunch and I'll show you what we're going to do in order to do the mean and the standard deviation, because you do not want to do this by hand. All right, so let's go over here. And let's just go into chapter 5 and I'll pull up, just randomly pull up a homework problem in here so we can get to Statcrunch. Easier this way. Okay. Here we go. Oh, what's she saying? Okay, somebody's losing service. Okay. Let me see, who is that? Amber. Okay, that's no problem. All right, let me get to Statcrunch.
Can I ask a quick question?
Sure.
What's the difference between this problem and the one in the book that says that it's not a numerical random value because the values are actually measuring categorical data?
Oh, it depends on what they're asking there. Because ours, let me go back to ours and show you. Ours is looking at, it depends on the description of the problem.
Okay.
This one says, these were groups of adults were randomly selected and arranged in groups of 3. The random variable X is the number in the group who said they're not comfortable in a self-driving vehicle.
Okay.
So this is legitimate that it goes from 0 to 3. The one you picked might not be, they might be groupings. I'd have to look and see. What are you looking at the textbook now?
Yes, ma'am.
What problem is it?
Job interview mistakes. It's like inappropriate attire.
What's the problem number? Do you know?
It's table 5.2, example
Let's see.
2.
Oh, it's example. Okay, hold on. Let me see. I got the book right here. Example 2. Oh, here's why. This one here?
Yes.
Okay, because these are not numerical. The values for X have to be numerical
Okay.
because
Gotcha.
these are categories. That was like the example we did before for eye color and then responses to the survey question, what political party. These have to be numbers. That makes sense?
Yes.
See, the ones we're dealing with here, we have numbers over here. There has to be numbers for the values of the random variable. They can't be discrete. They can't be categorical things like this. Because when I go to do the expected value, I have to take the value, each outcome value, and multiply it by the probability. I can't do that when it's words. Because when I do the expected value or the mean, I'm going to take 0 times this probability plus 1 times this plus 2 times this. So these have to be numerical. That make sense?
Yes.
Okay, good. All right, let me go back over to, is this where I have it? Yeah. Okay, so what I'm going to do here, and I always like to label stuff so it doesn't get confusing. So what I'm going to do is I'm going to put in the X values from the problem we were just looking at and then put in the probabilities. Whoops. All right, so the one we just did, we had 0, 1, 2, and 3. This is one for the self-driving cars. And then I'm just going to put in the probabilities that were given, 0.358, 0.439, 0.179, and 0.024. Okay, so that's exactly what we had in the table that I gave you on the little note sheet for this week. Now, I want to find the expected value and the standard deviation. So what I'm going to do is I'm going to go to Stat, Calculator, all the way down the bottom. Let me pull it up so you can see it. I'm going to go to Custom. And I'm going to pick the values. This means what are the values of the random variable? And I label that column X. The weights are the probabilities, P of X. And then just hit Compute. And here's your mean. Here's your standard deviation. So instead of doing that horrible formula, Statcrunch does the tough work for you. Let me go ahead and write them on the paper. So the mean is 0.869 and the standard deviation is 0.78, let's say 48. If they ask you for the variance, you would simply square the standard deviation. I don't remember in the homework if they do. I can't remember. They might. But if you were going to do a variance, I'll write this on the paper when we go back over. You would just square the value that's given here for the standard deviation in order to get the variance. Okay. Now, a lot of your homework problems, a lot of them are already set up for you. You just have to click to open up the little table in here. You don't have to actually enter the data. But remember, it's Stat, Calculator, Custom. Tell it where the values are for the random variable, and then tell it where the weights or what we call the probabilities are, and then just hit Compute. And the output will show you the mean and the standard deviation. So pretty easy, actually, now that you use Statcrunch for it. You don't want to do them by hand. It's awful to do by hand. Okay, so I went ahead and I wrote them on the paper here. So again, if they want the variance, you would just square what you calculated for the standard deviation. Okay. All right. Okay, we've got another one. Okay, so how about this one? So this is kind of like the one you had in the book. In Microsoft Instant Messaging Survey, respondents were asked to choose the most fun way to flirt, and the results are shown in the table. By email, in person, instant message, or text message, and here's the probabilities. Does it meet the criteria for a probability distribution? Are these numerical outcomes? Not a random variable, because these are not numerical outcomes. Because think about that formula for mu. You take X times P of X. I don't have an X value here. I've got words. So how would I calculate the mean? Whoops, sorry. I let somebody in and I disconnected the screen. So there wouldn't be any way for me to calculate an expected value because I don't have numbers here. So this is not a random variable and this is not a probability. It might be a probability distribution, but it doesn't meet the criteria that we need. I don't even need to check to see if it adds to 1. It doesn't matter. Okay. Now, how about this one? This is the number of golf balls ordered by customers of a pro shop has the following probability distribution. Find the mean and standard deviation. This is a probability distribution. So again, we've got 3, 6, 9, 12, and 15, and here's the probabilities. And again, I'm going to jump back over to Statcrunch. Yeah, there is a noise somewhere. It sounds like somebody's sleeping. So I'm not sure what that is. Somebody just asked about that. So, okay, let's get back to Statcrunch. And I still have that screen open. I do. I can just go ahead and put the date in here. So I'll just go over here and I'll call this, actually, let me call it Y and then probability of Y so we don't get confused. Yeah, somebody's got their audio on. If you could just mute it, it's bothersome if you're not talking because it makes a reverberation. All right, so what do we have? 3, 6, 9, 12, and 15.
Excuse me, Professor.
Yes.
Zainab got disconnected and she's waiting in the meeting room.
Okay, I just put her in. Hold on.
Thank you so much. Appreciate it.
There she goes. 0.14, 0.29, 0.36, 0.11, and 0.1. Okay, so again, this is the golf ball problem, and all I did was put the data into Statcrunch. I picked Y instead of X, just so we know when we go to Stat Calculator Custom, and I go to pick the variables, I'm now going to pick Y and the probability of Y. Compute. Okay. So on average, the customers pick order 8.22 golf balls with this standard deviation. So mu 8, actually, if you just use one more decimal than the original number, so 8.2, and the standard deviation is 3.4. Okay, somebody's really making noise in the background. Hold on just a second. Let me see if I can see who's not muted. Mute this one. I'm just looking to see. I think I might have just found the one that wasn't muted, so I think we're okay now. All right. Oh, let's go back over to Statcrunch just for a second. All right. So does everybody get the steps over here? So you're going to put your random variable values, the possible values for the random variable in one column, the probabilities in the other column, and then you go to Stat, Calculator, Custom, tell it where the values are for the random variable, and then tell it where the probabilities are, which this calculator calls the weights, which is the same thing. And then just hit compute, and you'll get output like this, and your mean is right here, and your standard deviation is right here. Okay. All right, let's go back over because this next one.
Dr. Reeven?
Yes.
Are we gonna have to manually, I hate to ask a repetitive question, are we gonna have to manually input it this week in regards to our homework?
No, they're all going to link right into Statcrunch.
Okay, roger that.
Yeah. In fact, while we're here, let me just show you that. I just had to do that because of the problems, Chris, that I did on the paper. So I mean 5.1, yeah, we are. Okay, hold on just a second. So let's get to one where you have some data. Here we go, let's see. Oh, I think it's further down actually. Yeah, here we go, it starts at 11. You don't have that many problems to do. Here you go, there's a link right here. Okay, so you click that, you can open it right in Statcrunch. But remember, the first thing you want to do is make sure it's really a probability distribution, and you answer that in the first part of the question each time. And then if it is, then you're going to go ahead and find the mean and the standard deviation. Okay, so you won't have to input those in yourself. And you only have 5 to do, so let's see, this one comes up this way. And again, the data is linked right there. Yeah, they're all linked for you. Make your life easier. Okay, so let's go back over and, oops, back to the sheet, because the last one we can just do on a piece of paper. So in this case, I gave you the probability distribution, and we're just going to answer some questions from it. So it says the table describes results from 8 births from 8 different sets of parents. The random variable represents the number of girls among the 8 children. Okay, so the girls could range from 0 to 8, and then the probability of among the 8 children having that many girls is given in the table. And this is just going to be practicing reading from the table. What's the probability of getting exactly 1 girl in 8 births? What's that value from the table? You don't have to go to Statcrunch for this one. You can just answer it using the table. What's that probability? Exactly 1 girl.
0.031.
Okay, we just read right off the table. Now, what's the probability of getting 1 or fewer in 8 bursts?
0.035.
Yes, you're right, because you're going to have to add up the first 2 categories because 1 or fewer means 0 or 1. So that's going to be 0.035. Now, which probability is more relevant for determining whether 1 is significantly low number of girls? And let me go back to the definition when we talked about significantly low and significantly high so that you understand where this is coming from. Okay. So for significantly low and significantly high, so we're talking about significantly low. X successes among N trials is significantly low if the probability of X or less is 0.05 or less. Notice this right here, X or less. So not just X, but X or less. So look at our problem again. Oops. Our problem. We wanted to know if 1 is a significantly low. So are we going to use part A or part B probability to answer that? Given that definition I just showed you, it says what? 1 or less. So which probability am I going to use?
B.
Part A or part B?
B.
Yeah, part B. And let's look at the possible answers. So let's see, since the probability of getting 1 girl is the result from A, this is the relevant probability. Since the probability of getting 0 girls is less likely than 1, the result from A is the relevant probability. That doesn't make any sense. Since the probability of getting more than 1 is the complement of the result from B, this is the relevant probability. Whoa, that doesn't make sense either. Since getting 0 is an even lower number of girls than getting 1, the result from B is the relevant probability. There's your correct answer. Again, based on the definition for significantly low. Now, and then they want you to find the mean and the standard deviation for the number of girls in 8 bursts. So in order to do that, now we are going to have to go to Statcrunch. So let me go over real quick and we'll put the numbers in and do it real quick. And I just need a stack. Oh, let me just preview and open up Statcrunch again. So again, you're not going to have to put the numbers in yourself because they're going to all be loaded for you. But here we go. All right, so I'm going to put in here, I'll put X on. X. Oh, it doesn't want to go in. Come on. There we go. And it went 0, 1, 2, 3, 4, 5, 6, 7, and 8. And then if I put my probabilities in 0.004, 0.031, 0.219, 0.273, 0.219, 0.109, 0.03. Oops, I missed one. I'm off by 1. So let me see, what did I miss? 31, 109. Oh, I missed 109. Let me get back up. 0.109. Oops. 09. 0.219. 0.273. 0.219. If you notice, this is totally symmetric, actually. Whoops. 219. And then 0.109. 0.031. Oh, come on. Geez, I'm not looking at the screen. 0.031 and then 0.004. If you notice, it starts at 004, goes up to 273, and then it comes back down with the same probabilities. And then again, if you go calculator, custom, I'll put in X, and I forgot to label the second column, but the probabilities of the weights are in variable 2. And so as you might expect, the expected value of the mean is 4. So among 8 children, on average, we would expect to have 4 girls. And there's your standard deviation, 1.4. So I'll dot that over here. Mu equals 4, and our standard deviation is 1.4. Okay. Well, let's go back over. I think that's the last problem we had for this section. All right, and I went ahead and jotted that down there. Oh, blank page. Oh, here's the answers. Okay. All right. So now we're going to go to 5.2. All right. So now we're going to talk about one special kind of discrete probability distribution, which is the binomial. And this is a pretty important one in statistics because a lot of things can be modeled by a binomial distribution. It has 4 requirements. Fixed number of trials. The trials have to be independent, meaning the outcome of any one trial doesn't affect the probabilities in the other trial. Each trial must have all outcomes classified into exactly 2 categories that we call success and failure. And the probability of success remains the same in all the trials. So 2 outcomes only in a binomial. And we just randomly pick a success and a failure. It doesn't always mean that what we would call a success is a success, but just by the nomenclature in statistics, we always call one a success and one a failure. Okay, so probability of S, we call S the success. Probability of S is going to be lower p, probability of success. And then the probability of a failure, because there's only 2 outcomes, is 1 minus p, which we also call Q. N is the fixed number of trials. And then if we're dealing in a particular problem, we're going to be interested in so many successes, and we call that X. And P is the probability of success in one of the trials. We don't define it up here. Q is the probability of failure. And then P of X is the probability of getting exactly X successes among the N trials. Okay, and then define the probabilities. You can use the table, you can use a calculator, or you can use Statcrunch. And we're going to use Statcrunch. But here's what the formula looks like. So if you're looking at X successes among N trials, and X can go from 0 up to N, you're going to take the probability of success that many times. So if you're looking for 2 successes, you would take P to the 2 power. And let's say we're doing 10 trials. Then Q would be 10 minus 2 would be 8. And then out in front here is all the different ways the successes and failures can occur among the trials. We call these the combinations. Again, you're going to use Statcrunch, so you're not going to do these calculations by hand. The next calculations, though, you are going to do by hand. For the mean and the standard deviation of the binomial distribution, very easy. The mean is simply N, the number of trials, times the probability of success. The variance is simply NPQ. And then to find the standard deviation, you take the square root of the variance. So these mean and standard deviation here is really easy, unlike the one we just did in the last section. These you will do by hand. Statcrunch doesn't do these for you. We're going to use the same range rule of thumb that we used before. Values that are below mu minus 2 sigma are significantly low. Values above mu plus 2 sigma are significantly high, just like we did earlier on, all through here. And then again, significantly high means X or more successes, significantly low, X or fewer. So just like I showed you in that last example, that's why I wanted you to see that example to understand what that means. All right, so let's take a look at some problems. The first kind of problem you're going to see is it a binomial or not? Okay, so, here's a problem first. I'm not even asking you that. Down here, I'm going to ask you that. Okay, so assume we want to find the probability that when 10 US adults are randomly selected, exactly 4 will agree with the statement, self-driving cars are safe. Assume 17% of US adults do agree with this statement. So what's the value of N for this particular situation? How many adults did we pick? How many trials are we going to do here?
10.
10. How many successes were we looking for?
4.
4. Yep, that told us that in the problem, exactly 4. What's the value of P for this problem? First of all, what's a success? A success is if we pick somebody and they say what? They agree with that statement. So what's the probability that they agree with that statement?
4/10.
0.17.
Yeah, 0.17. They gave us that in the problem. And then what's the value of Q? Remember, Q equals
Failures.
the failures, which is 1 minus P. So in this case, it's going to be 0.83. Now, when you're going to use the Statcrunch tool, the things you're going to need are this, this, and this. Okay, you're not going to put Q in, you don't have to worry about that, but they're going to ask you to put those into the tool. Okay, now let's look at some situations to decide if they are binomial or not. So let's take a look at a couple. I just want to look and see. Yeah, I should have put these in before I started. Okay, I'm gonna have to, well, it's okay. Your tool is pretty easy in this section. Okay, so we want to determine if this is or is not a binomial. So look at the first one. It says 10 different senators from the 116th Congress are randomly selected without replacement, and the number of terms they have served are recorded. Is that a binomial?
No,
No, you're right. Why not? It's not binomial.
there's not two categories.
Right, there's more than two outcomes, right? Because we're asking them how many terms they serve. So there's many outcomes, not two. So this is not a binomial. Let's see, did I say anything else? Let's see. Yeah, and we're sampling without replacement. So first of all, this is a finite set, right? Senators, how many senators do we have in Congress? Anybody know?
100?
Yes, and every time we pick, we have a lot different likelihood of getting a different senator. So really the probabilities probably don't even stay the same. So, but mostly because there are more than two outcomes. How about this one? In a US cellular survey of 500 smartphone users, subjects were asked if they find the abbreviations such as LOL or BFF annoying, and each response was recorded as yes or no. Is that a binomial?
No.
Oh, recorded
Yes.
as yes or other. I'm sorry. It was recorded as yes or other. Is it binomial?
Yes.
It is. There's only two outcomes, yes or other. So it's okay. It's a binomial. Now I changed it up a little bit. Same scenario, but now I said they recorded yes, no, or not sure. Is this a binomial? How many outcomes now? 1, 2, 3. This is not binomial. See the difference between the two scenarios? It's the same situation, but up here there's only two answers to the question. Down here there's three. So this is not binomial. This one is binomial. Okay. So now we're going to look at a problem and we're going to extract n, x, and p. These are the things that you need in order to use the tool in Statcrunch. So it says, based on data from a Harris Interactive survey, 40% of adults said they prefer to get their news online. 4 adults are randomly selected. Find the probability of getting exactly 3 who prefer to get their news online. Okay, how many trials do we have? What's n equal in this case? How many adults were selected?
4.
4. And how many successes are we looking to find among those 4? Exactly 3. What's the probability of success? So we're going to define success is that they say they prefer to get their news online. What's the probability of success?
0.40.
Right? Okay. All right, so let me flip over to the tool and show you, on my mouse here, how you do this. This is another calculator in Statcrunch. It's called the binomial calculator. All right, so you're going to go to Stat, Calculator, Binomial. Okay, I said you have to put in n, and our n in this case was a 4. Our probability of success was 0.4. And now, this is where you have to be careful. You have a drop down here, and you have a lot of choices. We're going to do equal to, and they just asked me to find out equal to 3. There's my probability, 0.1536. So the probability that x is exactly equal to 3 is 0.1536. Watch out for this right here, because you want to make sure that you're putting in the right direction for the probability. Sometimes it's going to be less than, sometimes it's going to be less than or equal to, sometimes equal to. This is the part where students have the most trouble. Make sure you set that correctly. So to use the tool, you need n, probability of success, and then the number of successes is going to go here, and then you need to pick the right comparison here. Okay. All right. Okay, let's flip over and do another one. So let me go back over to the screen. And so in a certain college, 33% of physics majors belong to ethnic minorities. If 10 students are selected at random from the physics majors, what is the probability that no more than 6 belong to an ethnic minority. Okay, what's my N this time? How many students am I picking?
10.
10. Now, what's the X value that I'm interested in? How many successes? It's 6, right? But we're going to have to be careful when we go over to the Statcrunch tool, because what are we going to do? We want probability and we want a 6 there. What are we going to do in here? No more than 6. So what am I going to put here as my comparison? Greater than, less than, equal to? No more than 6.
Less than or equal to.
Yeah, very good. Less than or equal to. You could also do less than 7. It'll get you the same answer. I like you better to focus on this one, though, because the 6 was given in the problem. And what's my probability of success here? 0.33. Okay. So let's flip back over. I wish I could show the tool at the same time, but unfortunately I can't do that. So I'm just keep using the same tool because I don't have to change it. So I'm going to put in my N, which was 10. My probability of success was wrong key, 0.33. Now I want less than or equal to 6 and compute. There's my probability, 0.9815. 0.98. Usually I think they ask you for 4 decimals on your homework problems. 9815. Okay. Go to the next one on the worksheet. Okay, an airline estimates that 94% of people booked on their flights actually show up. If an airline books 73 people on a flight for which the maximum is 71, what is the probability that the number of people who show up will exceed the capacity of the airline? How many trials are we doing here? How many people are they booking?
73.
73. Now, if it's exceeding the maximum capacity of the plane, what's the X that I'm interested in? How many do I have to show up to exceed the capacity?
71.
Well, 71's capacity.
2.
So to exceed it, I need 72. Exactly. Yeah, this is a little tricky one. And what's the probability of showing up? 0.94. Right? It's a little trickier because the maximum capacity of 71 is not the trials. We're booking 73 people, and we want to know what's the probability that we exceed capacity, which means 72 of those people show up. All right, so let's go back over to our tool. And let's put in again. I can just keep using the same tool over and over again. So I've got 73 people, and the probability that any one person shows up is 0.94. And we want to know the probability actually overbooked would be 72 or more. Let's do greater than or equal to 72, because if 73 people show up, it's also a problem, isn't it? So let's do actually greater than or equal to 72, not just 72. All right, that's not too bad actually. 0.0618. So probability that X is greater than or equal to 72 is 0.0618. So there's about a 6% chance that they're going to be overbooked. Now you can see why they overbook planes, because that's not a great problem. It's not huge. And they might have to give some free stuff away, but maybe it's worth it so that they don't have empty seats. All right. And then one more. Based on a Comcast survey, there's a 0.8 probability that a randomly selected adult will watch primetime TV live instead of online on a DVR, etc. Assume 7 adults are randomly selected. Find the probability that no more than 3 of the selected adults watch primetime live. All right, so what's my N in this case? N is going to be
7.
7. Now, no more than 3. So my X is 3. So we're calculating what? X and 3, no more than 3. So what's my comparison going to be in here? No more than 3 is going to be no more than 3. So this is going to be less than or equal to 3.
Equal to or less than.
Yeah. And what's my probability of success? 0.8. Okay. And let's go back over to our tool. Basic. So I've got 7 people. Oops. And the probability of success is 0.8. And we wanted to know less than or equal to 3. And I get 0.0333. Okay. The probability is very high, 0.8. So you would expect to have more than that among the 7 people. Now there's a follow-up question for this one, which you're going to see on some of your problems. So I put it on this question so you could see what they might ask you. Is this 3 a significantly low number of adults to watch prime time live? Remember, significantly low, and the comparison was 0.05 or less. So is this significantly low? Is 0.033 less than 0.05? Is this?
Yes.
Yes. So it is, because the probability of this occurring is small. So this is a significantly low number in this particular problem. And they're going to have that follow-up question on some of the questions. Okay, and then we're going to do now you're going to do these without Statcrunch. These are by hand. Find the mean and the standard deviation for a problem. A survey for brand recognition is done, and it's determined that 68% of consumers have heard of Dull Computer Company. A survey of 800 randomly selected consumers is to be conducted. Find the mean and the standard deviation. Okay, so how many trials do I have? How many people am I picking?
800.
800. And what's the probability of success?
68%.
Yep, 0.68.
0.68. Excuse me.
Now you're going to need Q this time, because you're going to be doing, this is 1 minus P. You're going to be doing a calculation with P's and Q's when you do the standard deviation. So 1 minus Q is going to be 1 minus 0.68, which is 0.32. Okay. Now the formulas for mu and P. So all you're going to do is multiply N times P. So 800 times 0.68. 800 times 0.68. So 544. So if we took random samples of 800 consumers over and over and over again, on average, we would expect 544 in that sample to have heard of Dull Computer Company. And then they want the standard deviation. So this, the standard deviation is going to be the square root of NPQ. So 800, P is 0.68, 0.32. So this time you do need the Q. Okay, so we already did this part because we did 800 times 0.68. So now we're going to multiply it times 0.32 and then take the square root. There's my square root. So 13.19 I got. 13.19. Okay, these you're going to have to do by hand. Okay, Statcrunch doesn't do these for you. All right, now for the same problem, use the range rule of thumb to find the values separating results that are significantly low or significantly high. So significantly low is mu minus 2 sigma. So my mean was 544. And then I'm going to subtract 2 times the value of a standard deviation. So 544 minus 2 times 13.19. And I get 517.62. And then likewise for significantly high, I'm going to take 544 plus 2 times, 13.19. Okay. So 544 plus 2 times 13.19, and I get 570.38. So there's my 2 values is to separate the significantly low from the rest of the others and the significantly high. So for groups of 800, with getting 634 consumers who recognize a dull computer company, would that be unusual? So is 634 greater than 570.38? Is this greater than this?
Yes.
Yes. So this would be a significantly high outcome. And if that were the case, what that leads us to believe is, or think that it's maybe 68% is too low of a percent. Maybe actually a higher percentage of consumers actually recognize the dull computer name. So maybe our assumption that 68% was the number, was a percentage, maybe it's actually higher. Because 638 would be, let's see, or 634 rather, 634 divided by 800, that gets us up to 79%. That's a lot higher. So maybe actually the percentage is higher than 68%. All right. Okay, how are we doing here? Oh gosh, we're doing really good. Okay. All right, let's take a look at what your homework looks like, because actually that's all we have to do for this week. A couple things I want to go over with you though. Let's take a look at your homework. I showed you the ones in 5.1. Let's take a look at the homework in 5.2 so you can see what that's going to look like. Let's close this down. 5.2. And again, you've got videos again because you're using Statcrunch. So let's go up here to where the problems start. All right, so now again, there's not going to be a link here into the tool because you're going to have to set the tool up each time. So it says, assume random guesses are made for 7 multiple choice questions on an SAT test. So there are 7 trials, each with a probability of success of 0.25. Find the indicated probability for the number of correct answers. Find the probability that the number of correct answers is less than 4. Okay, so you're going to go to Statcrunch. And you're going to use your tool, calculator binomial. And we have 7 trials. And we want to know less than 4, and it's 0.25. So 0.25, less than 4, so that's a strict inequality, less than 4, and compute. And how many decimals? Hold on just a second, I got to get the tools out of the way here. Yeah, 4 decimals, that's what I thought, 4 decimals. So 9294. So 0.9294. And that's all you do. Okay, so these are pretty easy. Again, you're going to have to set the tool up each time. Once you have a tool set up, it'll stay there. You can just keep using the same tool over and over because you just keep changing the N and the X and the P. So you'll just go through each of those. Read the questions carefully, exactly 6 on this one. What does this one say? At least 8. So at least 8 would mean 8 or more out of 9 adults. I choose, find the probability none. So that would be X equals 0. And this one, okay. I'm going to let you work on this one here. I will tell you though that this one is talking about, let me just describe it to you. I'm not going to work it because I want you to do the problem. The probability of a randomly selected adult in one country being infected with a certain virus is 0.006. In tests for the virus, blood samples from 13 people are combined. What is the probability that the combined sample tests positive for the virus? If it tests positive, that means there's at least one person in there that has the virus. So that gives you some hint about what you want to look for when you set up your tool, your Statcrunch binomial tool. Note that combined sample results are, there it is right there, positive, at least one person has the virus. So that's how you interpret that one. And you do it the same way with the tool. And then here's one about having baby boy, baby girl. So you're doing a mean and a standard deviation here. We just went over that. The mean is NP. We're doing 18 couples. The probability of a girl is 0.5. So NP would be 9. And then they're going to ask you to do the standard deviation. And then here is find the mean and standard deviation as a multiple choice. And then the mean, this is just a mean question. So I don't think your homework this week is very difficult, really. I wanted to mention a couple of things. Let me go over to my courses course for a second. So you have access now to a midterm module. So you've got honor lock information, and I forgot to look before class. I don't think a lot of people have done the honor lock sample test, but you want to take a look at the honor lock information. You must do that sample test before you have access to the proctored midterm and the midterm prep quiz in my stat lab. So you want to make sure you get that done. Here's your midterm exam materials. Okay, it tells about your test is going to open next week on Wednesday at 12 a.m. and be available through Friday at 11 p.m. Covers units 1, 2, and 3. Now we just finished the material for unit 3. So you'll have those 2 homeworks and the test due next week for unit 3. And then the midterm will open on, what's today, Tuesday, on Wednesday morning. Class next week, we will go over a copy of the midterm prep quiz. And then if you have any particular questions you want to ask me, we can do that also. But here's information about the midterm. And again, there's bonus points available. Let's take a look at the midterm prep quiz real quick. So here's a midterm prep quiz. And let's take a preview. And again, I will make available a copy for this to go over next week. And the first question on the prep quiz, which is the same thing that's going to be on the midterm, gives you some of the formulas. So there's the formula that we just talked about for the binomial mean and standard deviation, or variance rather. There are some of your probability formulas. And then your questions go in order of the material that as we learned it in the course. So unit 1, unit 2, unit 3. And I urge you to use this to help you get ready for the actual midterm, because the questions are going to be very similar. You will not use Statcrunch on the midterm because any output that you might need will be included on the exam. So you won't have to worry about using Statcrunch. I don't want you to get flustered that you forget the commands or something. I'd rather you focus on showing me what you've learned in the course. So much more interpretation and definition questions than it is. There's very few calculation questions. If they're calculation questions, they're very basic things that you can do on your calculator.
I have a question about the midterm prep quiz.
Mm-hmm.
It says that I believe for like 70%, you can get a certain amount of points, and I know you mentioned it. Is it saying on the first attempt? Because I know there's
no on any attempt, I'll take your highest attempt. So if you take it 4 times and you get 85% on one of them, that would be the one that I would use to calculate your bonus points.
Okay, thank you.
Because you can take it as many times as you want. Every time you take it, you're going to get a different set of questions. That's why it's really good to help you get ready for the test, for the for the proctored midterm. Okay, and the prep quiz will be open at the same time that the midterm is open. So you still can be looking at it while you're preparing for your midterm until Friday night at 11. So, but the idea is you take it ahead of time so that you can see what the test is going to be like. And please take your honor lock sample test. Remember, you get it from the toolbar up here through honor lock, and it'll walk you through how to do the ID check, the room scan, and then you'll take the little sample test in my stat lab. Honor lock will open it up for you. You'll take that. It doesn't count, but I just want you to see what happens and make sure that your computer's compatible, that your bandwidth at home is good, that everything's going to work right for you when you go to take it. Okay, let me see. Okay, Gabrielle, let me take a look and see. She's asking me if she did her sample test. Let me take a look and see. Oh, you have a different last name in here, don't you? Oh, Gabriella Delgado, I think it is, right? Is that right? Make sure I got your right one. Are you under? Okay, I thought that was someone there. Oh no, she has a different last name. No, it didn't go through. No, you might have an honor lock session, but you didn't actually do the sample test. So let me look at the honor lock sessions for a second. No, you don't have, hold on a second. Let me see. There's another screen here. You have a session, but you didn't actually submit the test. So you're going to have to submit it, because the only way you're going to get that access to the other things is if you actually do it. You have not done it yet. If you go into my stat lab, you'll see that it's showing there that you haven't done it. Okay. And also, let me just real quick show you this too, because there's also a video that might help you if you're not following what goes on when you use honor log. Let's go back over here. In the honor log module here, information module, the last item in here is a video. And if you watch this video, it'll show you, it shows a different course in this one, but that doesn't matter. It shows you what happens when you do the ID check, the room scan, and then how HonorLock will unlock your exam for you. I would suggest before you go into HonorLock, go over in your course and get that exam ready to go. So in other words, so you don't have to fumble around when you've checked everything. Go ahead and get this ready to go like this. So then when HonorLock knows you're okay, you've passed the room scan, the ID check and all, and you'll hit a little button there. It says enter the password. It'll know what exam to put the password into. All right. If you open the wrong exam up, it's not going to put the password in because the password is linked to the name of the exam. So you have to have it ready to go like that. Okay.
Wait, how do I get this password?
Say it again.
How do I get the password I need to do the proctor test?
HonorLock does the password for you. You don't have to worry about it.
All right, thank you.
Okay,
And
when you go through HonorLock up here on your toolbar, HonorLock will do that part for you.
okay,
Watch this video so you can see what happens. It'll show you what's going to happen.
perfect.
Okay.
And the midterm is open till next Friday, not this Friday.
Right, next Friday at 11 o'clock. Yeah, it's on your
All right.
calendar.
Perfect. Thank you.
Excuse me. Here it is on your calendar. So on Wednesday, it opens at 12:01 a.m. and it's open till 11 p.m. on Friday night. You get 2 hours to take it. You have to finish it once you start it. So make sure that when you're going to sit down to do it, you can have a quiet time in a place where you can, and make sure during a room scan, you need to show your scrap paper. You get 4 pieces, both sides, and show your calculator and also your work area. In addition to the room that where you're taking the exam, you have to show it with your webcam, or if you have a laptop, turn it around, move it around the room. And again, in that HonorLock module, there's also a, go back here for a second. There's a video here on how to perform a room scan. And you can also see that in the sample video too. Okay. All right. So we're finishing up really early tonight. So I can certainly answer questions for you, whatever you'd like to do. For next week, there will be, it's posted and I'll post it in the news area also. Let me go out there again and show you in Zoom class meetings. This is the copy of the prep quiz we'll go over next week. So this is what we'll do during class, in addition to any questions that you might have. But I posted this and I'll link it in the news area on the weekend so that you'll know what we're going to cover in class. So next week is really a review night for you to come with any questions that you might have on 5.1 and 5.2. Anything else from the course up to that point. And then we can go over this copy of the prep quiz together. It'll be a good review for everybody. Okay. And also in the midterm module, you also have a video that I made for class, I guess it was last fall. This is a different copy of the midterm prep quiz that I go over with them. So there's another tool for you, and there's a video where I go over that copy. So there's another review item. There's a review handout here, proctor testing information, etc. So you have lots of resources. All right, questions? Now's your time.
Are the questions from last fall that you went over with your previous class pretty similar to this term?
Yes. It's the same prep quiz. I mean, just because it's got a pool of questions, so I've just been using the same one over and over again. It's exactly the same.
Okay, thank you.
Anybody else?
Dr. Whiteman.
Yes, Lonnie.
Good question. When do you reopen up the homework assignments so that we could, I guess, go back and?
Oh, they're there. You can do them now.
Oh, okay. Okay.
Yeah, they're there. You can't go back to the test after the due date, but you can go back to any of the homework.
Okay.
Just
Awesome.
make sure if you worked on it before, when you click on it, it's going to say, do you want to improve your score or practice? Make sure you pick improve my score.
Yes, ma'am.
Okay, if you just pick practice, you're just going to practice and it's not going to keep track if you got a better score. But if you improve my score, pick a problem you got wrong. If you redo it and you get a better grade, it's going to say which grade do you want to keep, and then you'll have a higher grade. And I'll pick that up automatically each week when I update your grades.
Okay.
Okay.
Thank you.
Yep.
All right. And am I able to take the reading exit or reading test?
No.
Reading quiz again? No.
Nope, they're due before class. They're due on Monday night by 11 o'clock because I expect you to look at the material before class.
Well, I missed one somehow. Like, I mean, I
Well,
meant to do
every
it.
Saturday I sent you a reminder to,
Yeah.
oh no, yours comes out on Sunday. I send you a reminder Sunday to any student who hasn't done the reading quiz. So I don't know how you could miss it. It's on the schedule and I send a reminder on Sundays. Religiously, I go through and I say who didn't do it and I send you a reminder. This is due on Monday night by 11 o'clock. So I dropped the lowest grade. So if you miss one, it won't affect your grade.
Yeah, I saw that.
So, and that allows for the fact that sometimes, like Karen got stuck in the airport, I know. She got stuck in the airport with lousy Wi-Fi. I know that happens sometimes. So I dropped the lowest grade on that. Yeah, the idea is for you to look at the material before class so we can spend more time on problems than we do on concepts. I'd rather work problems with you than to go over all the definitions, repeatedly. Somebody has their hand up. Oh no, that's me. Sorry, I thought that was somebody's hand. It's my pointer. Oh, Karen's got her dog. What's your dog's name, Karen? You're muted.
His name is Crypto. He likes
Crypto.
to Zoom with us.
Crypto. My dog's sleeping somewhere. She had dinner before I started class, so she's taking a
That
nap.
was smart.
Yeah, otherwise she'll bark the whole time. All right. Okay, anybody else? We're finishing early, so it's your call. If you have questions you want to ask me, now's your chance. We have plenty of time.
Will there be any definition questions on the midterm? Or
Absolutely. Yes. Yeah, you need to look at that prep quiz so you can see what you're going to be covered, because I'm not having you do stuff in Statcrunch, so I'm asking you definitions and some simple calculations or interpretation of data if you're given output. So please look at that prep quiz because it's going to really help you get ready and understand the kind of questions that you're going to see. I can't stress it enough. Students who use the prep quiz on average score 15% higher, 15 points higher than students who don't use it. So I urge you to do it, to take it as many times as you want. And if there's any questions that you don't understand, that you get wrong or whatever, you can always write to me and say, I don't understand why this was wrong. Just send me an email and I'll go over it with you.
Is our final going to, sorry, I didn't mean to be rude. Is our final going to be cumulative?
No. Your
So
final's on the last 3 units. So
Okay,
it'll be on units 4, 5, and 6.
Roger.
Okay, great, Karen. I saw your message. Good job. Good. Good. Yeah, Karen's reminding me there is tutoring available. So if you need help, you can go. Let's just take a look for a second. You can make an appointment with a tutor. I mean, you can contact me and we can make an appointment too. But on your student tools on your homepage in my courses, if you go to library and tutoring. Hello. Come on. Tutor.com. I don't know whether they're good in this or not, but tutoring services is here at the college and you can actually make an appointment with a live tutor. You can either do it through Zoom or you can actually, if you want to come to campus, you can actually meet with a tutor. And I don't know if they list, yeah, see here in person, office appointments. And I don't know if they list for you who, if you put in, here we go, their subject list here. There you go. And they'll tell you who the people are that can do, here's math. Okay. And there's live study rooms and you can see who's at Gibbs campus. And here we go, Gibbs math. There you go. So who are the tutors for Gibbs math? Here we go. Oh, this is showing all the campuses actually. So they all pop up and when you go by topic actually. So this is in math and then you can even drill down more. Let's see, here's statistics. So there you go. Okay. So there you go. So there's lots of tutoring available for you if you want to use tutoring. And you can also ask me to set up a Zoom session with you. It's also a possibility. Okay. All right. Anybody else? Questions? So you're almost halfway through the semester. That's great. Next week is the halfway point. So halfway through, and it's a fast semester. So you guys should be really proud that you're doing, class is doing very well. All right. So try to get that honor lock sample test done as soon as possible so you have access to that prep quiz, because you're not going to have access until you do that. And then once you've done that, then when you go into, in fact, if you go in there now and see it, it's going to say you can't see it until you do the, let's take a look and I'll show you what I mean. It's going to say you can't see this until you do the, well, let's do test up here. So I don't have to look at everything. So if you go right here, it's going to say you can't do this. You have to do the honor lock sample test before you start the assignment. Okay, and then once you've submitted that, then that little green flag will go away from here and you'll be able to get to this prep quiz.
I actually have a question, please.
Go ahead.
About the honor lock sample test. I don't know. I don't know. I can't get the first question right. The one about, it's asking about,
okay, it doesn't, I don't count it, but you can't get it right. Let me, I don't remember what the question.
How do you, when you go to the, I've done it a couple times. I don't know. It's asking you about, when you ask for help on a test, on a question, is it, are you asking for the answers for one part of the question? Are you asking for help?
Oh,
I don't know. And I just can't. So are you, I guess my question is, are you counting that as one of
No, I'm not counting it. No, I just don't remember what questions I put on it. Let me just take a look real quick and see.
Okay. Yeah.
I think it might be, let's see, on a question, when you finish the entire assignment, you would click submit to hand in your completed assignment for grading. On a homework assignment, you would click on check the answer to check. It's usually just the answer you just entered, I believe.
I've taken it like twice and I don't know why I can't get it right.
I don't remember. I have to look at it offline to see, because I just picked a couple of questions randomly from the introduction to the course. It's either this one or the third one.
Okay, but you're not counting it as.
No,
like,
I'm not counting it. No, it's not counted. No.
Right.
No, it doesn't count. No. And I apologize. I didn't mean to give you something that was hard to do like that. I'm sorry. I just randomly picked a couple that didn't have to do with graphing and stuff, because a lot of the orientation questions have to do with graphing. And I was like, I don't want you to worry about graphing. Yeah. Hold on. Let me stop sharing for a second. And I can take a look and tell you. I don't remember what the answer is, honestly. Let me just look real quick. Preview. Let me just see, because I could answer it offline here and see if it's this one. No, it's not that one. Nope, not that one. Okay, so I think it's the third one. Nope.
And I was trying to research it on my own, and
it's the active part of the question. All the answers for the active part of the current problem.
Oh, okay.
Is that the correct answer? I'm sorry, I just didn't remember when you asked me. I'm like, oh, I don't even know. I just picked questions, you know.
Okay. Thank you.
Yeah, so somebody was just talking about the date for the due. Okay, so the midterm starts next Wednesday at 12:01 a.m. through Friday at 11 p.m. Okay, it's in this course schedule. It's on the calendar in my courses. Okay, and then the password. Somebody's asking about the password for the honor lock sample test. Honor lock will put the password in for you. You don't need the password. That's why I want you to take the honor lock sample test so you can see how honor lock works. Let's try it again. Let's go back here. Watch the video in the honor lock materials module so you can see what will happen. So let's take a look here. You don't get the passwords. Honor lock takes care of that part magically in the background for you. So right here is a video that shows you what happens when you use honor lock. Okay, so if you watch that video, it's like 5 minutes. You'll see how it works, and honor lock will enter the password for you. We'll unlock the exam for you. Okay, you don't need to know the password. That's all through the process of you have to pass the ID check, the room scan, and then once you get through those two, then HonorLock's going to say, okay, and you're going to get a little button that says insert the password. You do that, and HonorLock does that password insert for you. And then you're on your way, and it'll say start the test. Okay, if you take the sample test, you'll see how that works. And that's why I want you to do the sample test so you understand how it works. Okay. All right, so their password is not your worry. It's the worry of the HonorLock's artificial intelligence system. It is smart enough to know how to do it, okay? Letitia, did you have another question?
No, thank you.
Okay. All right. And I will continue to bug you for the students who have not done the HonorLock sample test because I want you to get it done so you have access to that preparation quiz. And then I know that you know that your system works too, that you make sure that you have the right, you have the plug-in on Chrome and that your bandwidth is good, you have a camera, all that kind of stuff. Okay. All right, I don't have any other material for tonight, so I kind of gave you a little light schedule tonight, so that kind of puts the burden off of you so that you can now think about finishing the homework and the test, but then getting ready for the midterm. And then the following week, we'll start back into Unit 4, and then we'll go through the material for the last half of the class. All right, any last minute questions? Otherwise, you're free to go. I'll stay here if anybody needs help, but otherwise, have a good week.
Good night, Deb.